Or you can just be like me and do it anyway. Yeah, lovely to see you all. Hope you're all doing well. So what we're going to do with this lecture is basically pick up where we left off last time, talking more about the basic structure and the grammar for first order logic. So here's the plan. I don't think we talked about Pokemon last time, did we? Yeah, okay. I figured people would remember if we had. So we'll talk quickly about empty predicates. So this will be a little brief moment where we'll talk about Pikachu and Pokemon, right? And then we're going to turn to multiple quantifiers and relational predicates. So we very briefly talked about this last time, but I want to kind of go through it because, again, this is one of the huge advantages of moving to FOL. Once we've done that, we're going to talk about a very special predicate, right? And that's the identity predicate. And once we have identity, and we're going to talk about how to use it, why it's special, and then we'll talk about how to use it. And it will let us say things like at least, at most, and exactly. And that's probably going to take us all the way up to the break, if not maybe even before. Once we get through identity and its uses, we'll actually segue away from just the formal logic stuff and talk about some philosophy of language meets formal logic. And this will be Russell on definite descriptions. And if we have enough time, we'll finish off by actually defining what an FOL sentence is. I fully expect we won't get all the way to here, but that's fine. We can reserve that for next week as well. Right? Big things I want to get through 1 through 4. So that's the plan for today, right? Finish up some stuff about multiple relations and quantifiers, and then get to identity and its applications. Cool? Cool. Okay. So, Pokemon. Now, when we set up first order logic, I told you that names can never be empty, right? If you have a name, the name always picks something out in a domain. But what we didn't say anything about was what predicates apply to. Predicates can apply to some, all, or none of the things in the domain. I'll say that again. Predicates can apply to some, all, or none of the things in the domain. A predicate that applies to nothing in the domain, we can call empty. So take this sample symbolization key. Our domain is just going to be people. Right? And we'll use two predicates. We'll have P is a Pokemon, and C is cute. Right? So on this symbolization key, unfortunately, predicate P is empty because people aren't Pokemon. Sometimes I wish they were, but they're not. Using this key, though, how would we symbolize all Pokemon are cute? So do we remember, what's the structure for every F is G? So the first thing we can do, right, if you hear all or every, right, yeah. Always the universal quantifier, right? And if it's the universal quantifier, vast majority of the time, it's going to go hand in hand with a conditional. So we can paraphrase this as saying, for everything that's a Pokemon, that thing is cute. That is, for all X, if X is a P, then X is a C. If we reach into our domain and we grab something that's a Pokemon, cool. We must have also grabbed something that's cute. Okay. So how would we do some Pokemon are cute? Yeah.
There is for some.
So we're going to use our existential.
Yeah, there is for some. If they are Pokemon, then they are also. That is both Pokemon and.
Yeah, there we go, right? If we use the existential most of the time goes hand in hand with a conjunction. Right? So some Pokemon are cute. We can paraphrase this as, there's something in our domain that's a Pokemon and is cute. That is like this. Now, here's the weird thing. On this symbolization key, is sentence 6 true? Is there something in our domain that's a cute Pokemon? No, right? Because people aren't Pokemon. How about 5? Is 5 true or false?
Yes.
Well, you said yes to a disjunction. Is it true? It is. It is. So here's why, right? This says everything, no matter who you pick to plug in for X, makes the conditional true. And what happens if you have a conditional with a false antecedent? Right? Do we remember? It's always true. So everything in the domain makes this conditional true. So here's something weird. 5 is true, despite the fact that 6 is false. And that's entirely because P is an empty predicate. P doesn't apply to anything in the domain. Or, generalizing, when F is an empty predicate, every sentence of the form universal conditionalized is going to be vacuously true. And it's vacuously true because the antecedent is always false. So the guaranteed falsity of that antecedent just gives us a true conditional on the cheap. It's a bit like when we had jointly inconsistent premises and how they would always guarantee an entailment, right? They guarantee the validity of the argument because that first part just lets us down. So that's something kind of fun. Right? Yes?
What does vacuously mean?
So vacuously means of a vacuum, like a vacuum, right? It's empty, right? It's emptily true, basically, because that first bit always just kind of...
That was also.
That was the same question. Okay, yeah. Yeah. Right. So, okay, cool. So that's something kind of fun, right? The big thing to take away from this, something to remember for next week as well, is that predicates can apply to some, all, or none of the things in the domain. Okay, so on to multiple quantifiers and relational predicates. Now, we talked a little bit about this last time, but it doesn't hurt to go over this again, right? So most of the predicates we've dealt with so far have been one-place predicates, and they express something like properties. What exactly properties are is a topic we're going to talk about in the second half of the course, but we can basically think about them as ways objects can be. Right? So is a footballer, is a philosopher, likes Pepsi, right? Is a good person. These are all one-place predicates. Contrast one-place predicates with two-place predicates. These express relations. And again, we'll talk more about what exactly relations are in the second half. But relations, well, they express relations between objects, right? So you might think loves is a two-place predicate. You have a lover and you have the beloved, the target of affection. Or you might have is adjacent to, or is taller than. Note in these, you always have to have at least two. You have something occupying the first space and something occupying the second. And you can go on. Three-place relations is in between. The corridor here is in between the C building and whatever that building is, I forget. Right? The hideous monstrosity that all the economists are in. Right? So again, to fill out the three-place relation, you got to fill in three terms. The corridor, the C building, the hideous monstrosity that's over there, right? Okay. There's no limit to the number of places a predicate can have. You'll sometimes hear talk about the adicy of the predicate, right? We're not going to worry about this too much. We're only really going to go at most up to 3, right? In fact, we're probably never going to get past 2. But importantly, when we fill in the places in the predicate, we need to be careful about how we do it, because it matters whether you're the lover or you're the beloved. Right? So we do this syntactically. Right? It matters how we write them down. And the gaps in how we fill it in tell us the different spots. So, for example, here's a sample symbolization key. We can have the domain of people. We can have little f be Fen, little b be Princess Bubblegum, and we can have our loves relation be expressed, right? The first thing loves the second thing. So in order to write Finn loves Princess Bubblegum, what we do is we put the name for Finn closest to the predicate, and then the name for Bubblegum, the next position down, right? So how would we write how would we say Finn loves Princess Bubblegum? Right? LFB. Right? This tells us Finn takes the first position and Bubblegum takes the second. And note, we could do this if we had a 3-place relation, right? Whatever would be in the third would take the third position in the predicate, and so on and so on. This is why when we write our predicate relations down, we can number the slots if we want to make it very clear who goes where. Yes?
So you can do L at 1,
If you want to, right? The thing to remember is if you put the little subscripts there, they're attached to those terms. And F1 might be a different name than F. So we want to be careful whether you're labeling the gaps or labeling the names. Does that make sense? Okay. So you can do like this, but if we write it like this, that suggests, because remember, names can have subscripts. That suggests we're saying that the thing named by F subscript 1 loves the thing named by B subscript 2. It's a syntactic, just an entirely kind of presentational difference, but it's important here. Right? It's better to just get in the habit of not having these and just let the order tell you who goes where. The one closest to the predicate takes the first position. The next one along takes the second, and so on and so on and so on and so on. Okay, so, right. No, it doesn't matter who we plug into the spots, right? We can plug the same object in twice. So how would we write Finn loves Finn? LFF. Yeah, nice. Right? How would we write Finn loves Princess Bubblegum, but Bubblegum doesn't love Finn? Yep. So we got the first half. LFB. How would we?
Conjunction, negation, LBF.
Yeah, right. So if Bubblegum doesn't love Finn, then it's not the case that LBF. Right? LFB. Finn loves Princess Bubblegum. Bubblegum doesn't love Finn. Right? We all know that she loves Marceline, the Vampire Queen. Right? Everybody knows this. Now, last one. How would we say Princess Bubblegum is loved by Finn? LFB, right? LFB. Because Finn is still the lover in this situation, and Bubblegum is the beloved. Right? Do we see it? We could paraphrase this in English as Finn loves Bubblegum. Right? Finn loves PB. Right? Now, again, everybody loves talking about Adventure Time. That's fair. But the thing to take away from this is how we can play around with filling in the spots in this relation. Right? Who we put in where tells us what kind of relation we're expressing. LBF is different from LFB. One of them is Finn loving Bubblegum. The other is Bubblegum loving Finn. Order matters. Now, importantly, as well as filling in names, right, we can also fill in these gaps with variables. So for example, using the same key, what does this tell us? There's someone who's loved by Finn, right? Finn loves someone. We don't maybe know who it is. Right? Similarly, what's this one say?
Yeah, someone loves Finn.
Someone loves Finn, right? Again, note the quantifiers, which one we put the variable into, tells us, are we saying there's someone who's a lover? Or are we saying there's someone who's a beloved?
Someone loves someone.
Nice. We're going to get to that, right? Next one along. What's this one say?
Someone who loves himself.
This one says someone who loves themselves. Because we have to replace the variables here with the same person, no matter who we pick. Right? Do we get it? Do we get it so far? So let's come back to your man's question. How would I say there's someone who loves someone?
It's an existential X, existential Y, and L, X, Y.
I need two quantifiers. I need two quantifiers to allow for me to pick two different objects. It doesn't force me to, but it lets me. Right? So we can do it this way. Yeah, sorry, help me. So again, right? This one forces us to plug the same person in for all of the x's. This one, we're permitted to pick different objects for the x and y. Not forced to, but permitted.
Does the order matter in which you put the existential X and existential Y?
Good. So when it's just like this, no. Right? But when we have different quantifiers, yes. I'm going to talk about that next. Right? But again, before we get to that, first things first, do we see, right? This one tells us Finn loves somebody. This one tells us somebody loves Finn. This one tells us someone loves themselves. Important, but we try not to talk about it too much in here. Right? And this one tells us there's somebody who loves somebody. So once we have relations, we can start to quantify into the different spots. Yes?
I'm so sorry, my head was just somewhere else. Where does the Y come from?
Good. So it's attached to our other quantifier, right? So we have the x attached to this quantifier, the y attached to this quantifier, and because we have two, it's possible for us to grab one object with the x and an entirely different object for the y. So I could fill in Finn for x and bubblegum for y. Whereas here, whatever I grab for x, I have to fill in for both spots. A way to think about it, right? Our existential quantifiers are a bit like the claws in claw machines. Right? This one, we've got two claws, so we could potentially pick out two different objects. This one, we only have one claw. And we might get lucky and, grab. It don't happen. Like, we only ever get one per grab. Okay. So now, to come back to your question. Yeah, sorry.
Oh, no.
Okay. It might come back. So here's the fun thing. Here's one of the reasons we're interested in this machinery. Right. Well, I mentioned this already, right? Pay attention to the order matters. Yes?
Is it still possible for the two variables to be the same?
Yes. So again, when we have this existential x, existential y, you are permitted to use the same thing, but you are also permitted to use different things.
So it could theoretically be the same as that one, but it doesn't have to.
It doesn't have to be. And because it doesn't have to be, that tells us these are different sentences. Okay. So now, let's talk about love. Everybody loves somebody, right? Everybody loves somebody in English is ambiguous between at least two readings. One reading says, for each person X, there is someone that X loves. Right? That is, each one of us, for every person, there's at least one person that we love. Right? It might be somebody different, right? It might be somebody different, but everyone has someone that they love. Contrast that with our second reading. There is some particular person that everyone loves. Now, we can express these differently. We can capture them differently using our machinery. And this is where the order of the quantifiers actually matters. Our first sentence we can say for every person. So for all X, there is some person, existential Y, such that X loves Y. In contrast, for our second one, we say there is some person for whom every person loves. These say different things. Our first one tells us, okay, go out, pick any person you want. Once you have them, once you've filled them in for X, you are then going to be able to find something in the domain that they love. So we can pick my wife Amanda, right? And then once we've got Amanda as our X, we're guaranteed to find something that she loves, our dog. Not the dog. We can pick me, right, as the X. And there's guaranteed to be something that I love, the dog, right? Sorry, Amanda. Now, importantly, for each person, you slot them in for X first and then go look for the Y. Yeah? That's what this one says. Now, contrast it with this one. What we have to do first is dig around in the domain to find the one thing that when we plug it in for X, it doesn't matter who we pick for Y, they're guaranteed to love them. We have to find the main character here, the Mary Sue, right? That's what it is, right? We have to find the person that everyone loves first here. Instead of picking each person and then seeing who they love, we find one person and then make sure that everyone loves them. It's a different process. And to capture the difference here, we had to use the relational predicates and multiple quantifiers. This is the huge advantage of this language. To give a peek behind the curtain. Not because these logicians were interested in love, but because they want to say things like every number has a successor. And they want to say it this way. They don't want to end up having to commit to the idea that there is some number that's a successor of every number. Because that'd be weird. It has to be its own successor. That's weird. Yeah.
Why don't you say everybody loves everybody?
Good. So that one's easy, right? How would we say everybody loves everybody? Everybody loves everybody. I mean, it's a beautiful idea. How would we express it?
Universal X, O, X, X.
So that's everybody loves themselves.
So for all X, for all Y, and LX.
Yeah, right? Everybody loves everybody. We need, just like here, we need two quantifiers. In this case, it's just going to be two universals. Now, we'll talk more about this in the tutorial, but something to let percolate. Sorry, I forgot you had a question. We'll come back to it in just one second. Something to let percolate in the back as we keep going on is think about how you would formulate there's someone who loves everyone. And we'll talk more about this in our tutorial, right? But let that little just click away. You had a question.
Well, maybe it's not relevant, but for the second one,
Yes.
there's some particular person whom everybody person loves. I would say, reading that will be necessarily false. Is that also the case if you do that more?
So it's not necessarily false, right? because we can think of scenarios where there is somebody that everybody loves. Maybe because there ain't many but one person left, right, who happens to love themselves. That would be a very cheap way to get there's some particular person everybody loves,
Yeah.
because this is the only person left, and I look out for number one, right? This is the kind of thing we're going to talk about next week. But yeah, it's important to start to see, well, all I'm worried about right now is getting that grammatical difference. We'll talk about evaluation later on. So was there a hand or was I? Okay. Cool. Okay. So again, the important thing for us is thinking about how we write these relational predicates. You write the predicate, and then the order that the terms appear, tell them how they're going to fill in the gaps. And you can quantify into these gaps. You can use existentials, you can use universals, and they let you say different things in different circumstances. Yes?
Is there like a limit to how many existentials you can give?
I mean, there's no limit to the number of places in a predicate. And if you got a 37 million place predicate, quantify into every one if you want, man. It ain't gonna be fun to write down, but you can, right? There are very few circumstances where that's going to be helpful, but it's there. It's something you can do. Okay, so what I want to turn to next is applying some of the stuff we just talked through. In particular, this idea about quantifying into relations, right? So in order to do that, we're going to talk about something I really enjoy, which is anime. So here's a sample symbolization key. Our domain is going to be people and anime. We're going to have little n for Nathan. We'll have A as the predicate is an anime. F is the predicate is a fan of, in that order. And R is the predicate is a friend of, in that order. So using this key, how could we say Nathan is an anime fan? Yeah, go ahead. Well, if we say F and X, right? First thing, we have to have a quantifier to go with the variable, right? Second thing, that don't tell whether the thing I'm a fan of is a person or an anime, right? So we want to make sure that whatever it is I'm a fan of is an anime.
Like Fn and conjunction AX.
Good. So we want to say, right, our thing X is an anime, and we also want to say that I'm a fan of that thing. So we want to stick conjunction there, right? FNX, to say Nathan's a fan of this thing, and this thing is an anime. But importantly, much as we said, there has to be a quantifier. So what quantifier is it going to be? If it's with a conjunction, what's the one that usually goes with conjunction? Existential. There is something that's an anime Nathan's a fan of. Right? Nathan's an anime fan. There's something that's an anime Nathan likes. Do we see it? Right? Okay. It does mean that it's as close as we can kind of get, I think. So importantly, we're not translating. We're trying to capture it as close as we can. Right? And this certainly tells us, given the setup, there is something that is an anime that I'm a fan of. Well, good enough for government work. How about someone is an anime fan? Someone's an anime fan. Well, we know how to say Nathan is. Yeah?
Is it existential X conjunction F?
Well, close. So let's think. If this one says Nathan's an anime fan, right? Can we take this and turn it into somebody is? Yeah. Right? We just kick out me, replace the N with a Y, and existentially quantify it. There is something, right, such that there is another thing, that's an anime, and our first thing's a fan of the second thing. There is some Y, and there is some X. X is an anime, and our Y is a fan of X. Yeah.
So you have one quantifier for someone,
Yeah.
and another quantifier for anime.
For the anime, yeah. Right? Because the way we're getting to make sure that the X is an anime is by ensuring it's an A. Yeah.
And the qualifier needs to be in this order.
So these ones we can switch around. It doesn't matter. So the important thing, the order doesn't matter if they're all the same quantifier. The order matters if you have existential and universal or vice versa. Those are the ones that matter. If it's just a bunch of existentials or universals, write them in whatever order you want. I don't care. Okay. With me so far? With me so far? So now, our last one. All of Nathan's friends are anime fans. All of Nathan's friends are anime fans. This one's a tricky one. So maybe we can help ourselves out, right? If we hear all, what should that immediately make us think?
Universal.
Yeah, universal, right? So all of what? All of, like, everyone in the domain?
All of this is friend.
All the friends of Nathan, right? All the things that are friends of me. So we know our beginning. Our beginning is going to be the universal quantifier for all X. If X is a friend of Nathan, right? If R Xn, conditional. So again, we can hear that as everyone who's a friend of Nathan is a fan of anime. For all X, if Rxn, then this thing X is a fan of anime. And now how do we fill this in? We know how to do this. We just did it a second ago. We can take what we have up here and slot it into the consequent. We just treat our X as basic as the N. So we can say X is a fan of anime. That is, there is something that's an anime, and X is a fan of it. For everything in the domain, if it's a friend of Nathan's, then there is something that's an anime, and our object X is a fan of it. Now, first thing to stress with this, if it don't click, don't worry, we literally just did it. Second thing to stress is note how what we did is we started off by doing this sort of construction, and as we got more complicated, you could always embed that opening construction. If you know how to do Nathan's an anime fan, then you know how to do someone's an anime fan. You just replace the name with an existentially quantified variable. You know how to do this because you can take that structure and plug it in as your consequent. If I'm going to give you something like this in the midterm, I'll always build it up like this, where you can get the initial structure and then figure out how to embed it.
I'm seeing that we get one.
I'm recorded, so. So that's the thing, right? Again, don't freak out. What we're doing is we're figuring out how to capture this English into the formal language we have. And by having these relational predicates, we can start to quantify into different positions. That's the real magic of this language. It lets us do so much that we couldn't even come remotely close to doing with TFL. It's awesome. Okay. Yes?
Can we move the existential qualifier to the beginning?
Yes. So one thing, and I don't think I mentioned it in the previous lecture, but one thing is if you have a quantifier, the scope of which is just a consequence of a conditional, you can move it to the front. But only if it's in the consequent. If it's in the antecedent, you cannot kick it out in the front. That's a different sentence.
sorry, in the case we were moving the existential quantifier in the front.
Yeah.
Then they will affect all the
and it
brackets.
ranges over the whole sentence, then that's totally fine. And actually, also because of in this case, because we've got the conditional, the order will be flexible. But importantly, if this quantifier scope had been in the antecedent, you cannot put it in the front. That is a no-no. That is a different thing altogether. We'll talk more about this kind of thing again next week, but yes. Okay. So far, so good? Again, I know throwing a lot at you, but hoping it sticks. Okay. Let's talk about identity. Right. Now, I want to stress, what we're going to do here is we're just going to talk about identity predicate in first order logic. One of the topics we're going to talk about in the second half of the course is the kind of philosophical understanding of identity. So that is how exactly identity works. For now, we're just going to talk about a special predicate in first order logic. So the equal sign is a very special predicate. It is a two-place predicate, but it is special in two different ways. First, it is the only one that we write in between terms. For all of our other relational predicates, we always write the predicate first and then the terms. Identity is the only one that you write in the middle. That's one weird thing. Syntactically, it's different. The second weird thing is that because it's a special symbol, we never have to define it. Every other predicate, we'll say what it means in some sense in our symbolization key. We never have to do that with identity. We can take it as given that the equal sign always expresses identity, and it only ever expresses identity. So you don't have to put in your symbolization key, oh, the equal sign means identity. We just know it. One other thing to mention is, just like the other two-place predicates, we can negate identity claims. So remember, if we said that bubblegum doesn't love Finn. Remember how we did that? We did not LBF. So we could do this, right? You stick the negation in front of the predicate. Well, we're going to do the same with identity. But because the predicate goes in the middle, it looks funny. If we want to say that A is not identical to B, we write it like this. So you put the negation in the front. You do not write this. You do not write that. That's nonsense. That doesn't make any sense. Right? You put the negation in front of the predication. So you can basically read it as this, right? It's saying it's not the case that this predication holds. That's just a syntactic point, but it's an important one. I've seen this sort of problem a lot. So. Okay. Yes.
So negation A is equals to B. Negation the whole thing bracket. Are they both equivalent?
Yeah. So importantly, it's not saying negation A.
Oh,
It's saying it's not the case that this identity relation holds. That's the important thing here, right? It's just like here. The negation is attaching to the predication, not to any term. Right? It just looks funny because we write the identity sign in the middle. That's the only bit. Yes?
How can you distinguish from negation A is equal to this one?
Yeah?
How can you distinguish from no A is equal?
That doesn't make sense. Because negation attaches to sentences. Right? It works just like it did with TFL. And a term by itself is not a sentence. It always has to be a predicate term, at minimum. So if it's just A, you can't attach a negation to it. It doesn't hook up in the right kind of way.
Okay.
It'd be like trying to attach a train car to the back of a car. Right? It's just like, cool, these don't couple in the right kind of way. You need more. Okay, so we'll talk about the kind of philosophical underpinnings of identity, and then we'll get to our break, I think. Right? So the identity relation, again, we'll express with this equivalence sign. Now, for our purposes, and we'll talk more about this in the second half, identity does not mean that the two things on either side are indistinguishable. Or, for that matter, that the same things are true of both of these objects, at least for our purposes now. There are heavy philosophical issues at play. This is what we're going to talk about in the second half. All we really mean by this is that, in principle, there could be a separation between things being indistinguishable, that is, satisfying all and only the same predicates, and there being identical. I'm going to talk more about whether that actual distinction makes sense in, week 14, I think, week 13. But identity does mean that the two terms co-refer. That is, that the two objects on either side are the very same object. So we could say Superman is Clark Kent and symbolize this as M equals C. That is, the thing named by M and the thing named by C are the very same object. These names co-denote. This is all the identity sign means in FOL. We'll talk more about this kind of philosophical meaning later on. So this is identity. Again, remember, it's special because we write it differently, and it's special because we don't have to define its meaning. So why the hell do we need it? What does it do? Right? Well, here we can help ourselves out. Let's consider this example. Right? Here's another symbolization key. We've got a domain of all people. We have a two-place predicate, which is hates, and we have little c for Scrooge. Right? So how would we symbolize Scrooge hates everyone? Using this key, how do we say Scrooge hates everyone? Well, so if we have HCX, we've got to have a quantifier. Which quantifier? Yeah, right? For all x, HCX, right? No matter who you pick for x, Scrooge is going to hate him. Now, importantly, if this is true, who's one of the people that Scrooge hates? Scrooge has to hate himself, right? Because Scrooge is one of the x's. So we might then wonder, how would we say Scrooge hates everyone else?
That one and the conjunction. And
I like it. So one thing, I'm digging it. We're not going to want to use a conjunction because that's going to say Scrooge hates, no matter who it is, Scrooge hates them. And but again, we might wonder, how will we say everyone else, or Scrooge hates everyone other than Scrooge? We can actually hear it if we think about it, right? Scrooge hates everyone else. So if Scrooge hates you, who aren't you? If Scrooge hates you, you ain't Scrooge. Cool, we know how to say that. Every F's G. For everything that's hated by Scrooge, it's not identical to Scrooge. Everyone who's not Scrooge is hated by him. That is, for all x, if you ain't Scrooge, you're going to be hated. Again, do we see the structure here? So, okay, let's talk it through. Right? Scrooge hates everyone else. We can paraphrase this as everyone who is not Scrooge, everyone who is distinct from him, who is not identical to him, is an object of Scrooge's hatred. So if we reach in and we pull something out of the domain on the assumption that it is not the case that it is identical to Scrooge, then it is guaranteed to be something Scrooge hates.
So X identical to Scrooge.
That's what this says.
Yeah.
And then we're saying it is not the case that you're identical, right? Identity is the very same as. So to say is different from is to say not identical to.
Then hypothetically, everyone that is identical to Scrooge is also not.
He could still hate himself, right? This doesn't prevent him from hating himself.
Yeah.
But that's okay, right? We could add in, and Scrooge doesn't hate himself, right? And not HCC, if we want to guarantee it. So this is why identity is so useful. It lets us start to say things like this. We can pick out particular objects and say, right, this thing and nothing else. Or only this thing. So what we're going to talk about when we come back from break is extending this machinery. Because once you have identity, we can start to say things like at least, at most, and exactly. And that's what we're going to talk about next. So, we're at 32. Should we come back at 45? Does that sound good? 13 minutes? Cool? Okay, let's take a break till 45, and then we'll go from there.